Welcome to qnawire.
I'm going to draw a diagram for this problem just to make it a little clearer what I'm doing. So we have a ball that's at the top of a cliff, which is 50 meters high, and a stone is thrown upwards as the ball is dropped. It's thrown upwards at 24 meters per second, and at some point they collide, and I'm going to call this point Y final. And now I'm just going to list everything I know for the stone and the ball. The stone is starting at the ground, the ball is starting at the top of the cliff. So initial height of the stone is 0. Initial height of the ball is 50 meters. We also know Y final is the same for both. We know our initial velocity for the stone is 24 meters per second. And our initial velocity for the ball, it's starting at rest and it's dropped, so its initial velocity is 0. We also know that A equals minus G. That's true for both of them because they're in free fall. And now I'm going to write an equation for both of them. I'm going to write it in terms of YF and not delta Y. So YF equals Y0 plus V0t plus 1/2 AT squared. And if I were to just bring this Y0 to the other side, we would get a delta Y. So it's the same equation. Now, for the stone, we know the initial height is 0. The initial velocity is 24. And this is a minus G t squared. So Y final, this is the expression for the stone, is going to be 24t minus 1/2 gt squared. And for the ball, we're starting at 50 meters. We have no velocity. And again, minus 1/2 gt squared. So for the ball, our expression is this. And now we can just set these two equal to each other and solve for time. So 24t and you can see now that these two terms are going to cancel nicely, so they're just gone. And we get 24t equals 50. So t is around 2.083, but I'm not going to round yet. And now, so we have the time at which they collide. We want to know the height. And so we can plug into either equation we got, but I'm just going to use this one because there's only one t in there. I don't have to plug it in twice. So our Y final is going to be 50 minus 1/2. G is 9.8. And our t, 2.083 squared. And our Y final ends up being 28.7 meters. And this is 28.7 meters above the ground. It didn't matter which equation I plugged into. If I did the other one, I would still get 28.7 meters. Either way, they collide at the same point. And this is the height.